Okay guys, so today what we're going to start looking at is solving linear equations. Here's just a little task for you to do, or even get your parents at home to do. I'm sure all of your parents are old enough to have been on Facebook that they would have seen something like this pop up. It's come up quite a lot, where you have different kind of symbols or different clip arts here and they equal a number. So you have to try and figure out then what the value of each of these are. Okay, so I'm going to leave that for you and your parents to have a go of. So if you find out the value of these, then you should be able to solve this final equation here. And I'm going to leave that for you and your parents or even your siblings to have a go at. And I want you to tell them that they never thought that they'd use algebra again when they learned it in school. But there you go now, on Facebook. Okay, so just a little recap on our language that we use when we're looking at algebra. This thing here, 2x, is what we call a term. Okay, and the number 2 is what we call the coefficient. So the coefficient, I'm sorry about my writing there. And also let's not forget that we call this thing a variable. But I know you guys know that already, we've talked about it so much. So that's a variable. And then when we have it like this, we call this an expression. So this would have been notes that we did at the very beginning. Okay, so 2x plus 4 is what we call an expression. And then finally, this whole thing, so when we have an equal sign, we call that an equation. Okay, so when we have the presence of an equal sign, we call that an equation. So if you want to just pause the video there just to take down that recap and just take down the definition of an equation. So it's when a term or an expression, so even we could have 2x is equal to 10 or 2x plus 4 equal to 10, as long as there's an equal sign. And when there's an equal sign, it becomes an equation. So we know that in this equation, 3x is 3 multiplied by x. And if I said to you, what would I multiply by 3 to get 9? I think every single one of you would be able to tell me that you would multiply 3 by 9, so that x would be equal to 3. So what does that 3x represent? Well, it represents x plus x plus x equals to 9. And if I'm to add, if we said that each one of those was 3, 3 plus 3 plus 3 equals 9. So you're correct. So in algebra, what we often do then to get this answer, so that's an easy one because you guys have learned in the last chapter that 3x means 3 multiplied by x, and you're all so clever that you'll be able to say that x is equal to 3. But in algebra, often what we do is we actually divide both sides by 3. And when we do that, you guys know from integers and from fractions that 3 over 3 just gives me 1. So that gives me 1x, but you know we don't put that 1 in front of the x, it's there, it's invisible. And then we get 9 over 3, which again from top heavy fractions, you guys should know that 3 goes into 9 3 times. So x is equal to 3. So what we do with one side, we do with the other. And that's our second rule when we look at solving linear equations. So that's a very important rule. What you do to one side of the equation, you must do to the other side as well. And that's called balancing the equation. So if I give you another question now, let's say 4x equals to 16. Press pause, go ahead and solve that for me, please. Okay, so what you should have done then was divide both sides by 4 so that I get x by itself. And we always want to get x, or whatever the variable is, on its own. So 4 into 4 goes once, and that's x, 1x, which it's invisible, the 1. And 4 into 16 goes 4 times, and that's my answer there. So let's have another example, and make sure to take all these examples down now because they'll help you. Let's go with 5x equals 30. Okay, pause the video, have a go, and then come back. Okay, so 5x equals 30, divide both sides by 5. And what I'll get is 5 into 5 goes once, so that's 1x, equals to 5 into 30 goes 6 times. So x in this case is equal to 6. Okay, so let's look at when we have an expression equal to a number. So now we have this plus 3 in here, so it's not as easy as just dividing across. What do we do in that case? Well, you remember a rule that we had about making sure that what we do to one side we must do to the other. That's a really important rule. So I need to look at this and say, well, I want x by itself. And I have a plus 3 here, and that's not good. So what could I do to plus 3? What operation could I do to plus 3 to get rid of it? Okay, and I know that if I took 3 away from it, I'll get 0, and that's exactly what I want. Now, to refer back to this rule, what you do to one side, you must do to the other. So I'm going to take 3 from the other side as well. Let's have a go now of fixing that equation. So I have 2x, I have plus 3 minus 3, which cancel, and then I have 15 minus 3, which gives me 12. Now it begins to look like something that I could solve. So what did I do before? Divide both sides by 2, and what I get is x on its own, and 2 into 12 goes 6 times, and that's my final answer. We often call this stabilizers. It's almost like the stabilizers on a bike, or the balancing method. So what you do to one side, you must do to the other. So you'd never cycle a bike when you're learning to ride a bike. You'd never cycle it with just one stabilizer. You normally use 2. Okay, let's take another example then. Here I have 5x, this minus 4, and I have 16. So I need to have a look at this and think, what exactly am I going to do here? Well, what's the opposite operation of take away? It's plus. And if I add 4 to that, I'll get that to be 0. Now, if I do that to one side, I must do it to the other. Okay, now let's go and try and fix this equation. So I have 5x minus 4 plus 4, cancel, and I get 16 plus 4, which gives me 20. And I can divide both sides by 5 to get x by itself. 5 and 5, they reduce to 1, and we don't put that in. And then 5 into 20 goes 4 times. And that's my final answer.